Welcome to What's New in Spring Data. My name is Oliver Gierke. I work for a company called Pivotal. Has anyone ever heard of Pivotal before? Spring Source, probably. So we're the guys behind the Spring Framework, basically working on it. My role is leading the Spring Data project. So basically everything that's sort of data related and not within the core framework is at one point in time passing by my desk, sort of. Yeah, if you want to reach me on Twitter or something, at Oliver Gierke, or drop me an email, what have you. So, who of you has heard of Spring Data before? All right, that's awesome, because we only have 50 minutes and there's such a lot of stuff that I could show you. And that means I can basically skip all the introductory foobar and don't have to explain repositories and query methods and all this kind of stuff. So what I'm going to do is basically just walk through a set of prepared demos. I don't think we're going to be able to have a look at all of them. As I said, some of them are rather introductory anyway. You can find them, the demos, at this repository that will be linked. It's just if you just Google for what's new in Spring Data on GitHub, and then you probably just find it. Don't be puzzled. It's under the Spring 1 organization, like for last year's Spring 1. We originally prepared the original version for that talk. There's also a general Spring Data examples repository where you can find like even more stuff that's not only concentrated on the features that are new, which is actually what we want to do. In the next couple of minutes. What do I mean when I say new? We have a concept called a release train. Spring Data consists of a lot of modules for individual stores, and we decided at one point in time that it might make sense to release them as a group, basically, and introduce so-called release trains, because they are all evolving at slightly different paces, and that caused them end up in different version numbers, and it was kind of hard for people to digest when they use JPA and Mongo together, which Spring Data Commons version did they have to use and stuff like that. So we came up with the release trains. Our current one in production is Gosling. The one that we just released the first milestone of is the upcoming one, Hopper. And it will be a mixture of mostly features in Gosling and Fowler. I have a few slides in the end about what's new and coming, and some of that stuff is already available in the milestones, and some of the examples have already been updated to those new features. So the release trains are also our means to basically control the level of dependencies that we depend on. Dijkstra back in the days is the last version that is compatible with Spring 3.2. Evans was on 4.0, Fowler was on 4.0, Gosling is on 4.1 in terms of the minimum Spring dependency. And Hopper is about to ship. Where is it? There it is. Hopper is about to raise that dependency to Spring 4.2. So while there, of course, you can even use, let's say, the Evans release train, which is the one that's currently included in Spring Boot 1.2. You can, of course, still use those with newer versions of the Spring framework, but this is basically the minimum baseline that you have to use. Anyone still on Spring 4.1 here? Spring 4.2? Most of you guys. What else? 4.0 even, or 3.2? Oh yeah, poor guy in the front. 3.2 is actually more fine than 4.0 because 3.2 is still maintained because it has Java 5 compatibility. In the 4 train, we basically only 4.2 is actively maintained. There are no updates to 4.1 anymore. But just to give you an impression, which train you have to look at in case you're stuck on a certain version. Yeah, got that. So I said we're gonna raise the bar to 4.2 for the Spring dependency. We also raised the Jackson dependencies, especially concerning the Spring Data REST module to 2.6. There's this kind of Spring.io platform project that we do for quite a while with Pivotal, which is basically a curated set of dependencies, and there's a 2.0 version coming, and that ships Jackson 2 as default dependency. Also Guava, which is usually a pain in the neck when it comes to upgrading. We're not really depending on it. We're optionally integrating with its optional types and stuff like that. But we expect Guava 18 on the class path for that. I mean, you probably can just downgrade it to 17 or 16 or what have you. It's just that we build against this version and be done with it. There's no strong integration. Store updates are quite interesting as well. The Gosling release shipped support for the MongoDB 3.0 server and Java driver. There were a few tiny tweaks that we had to do to Spring Data JPA to work with Hibernate 5. I'm not even sure that would affect you if you just run your application on Hibernate 5 with an older Spring Data JPA version, but we had to do some tweaks to our test cases to make it work with it. There were some changes in the configuration API in Hibernate 5. The same applies to the current 5.1 version. Causes a bit of hiccups in our build, but shouldn't really affect the production environments here. Okay. In case you're not using Spring Data with Spring Boot, and that's the final thing for the introduction, we released a so-called BOM POM, which not only sounds funny, but it's kind of helpful as well. A bill of materials, Spring Framework, Spring Integration, Spring Security all do that as well. That basically means you can import a POM into your POM in the dependency management section, and then pointing to the logical names. Let's say you point to Gosling release or Fowler SR1, and don't have to worry about like the concrete version of Spring Data MongoDB and stuff like that. It will always make sure you end up with the right set of dependencies. With Boot, you just get the latest and greatest anyway, but can tweak a Maven or Gradle property to upgrade. All right, so let's start with what's really new in the latest release trains. I'd like to start with Spring Data Commons because it's a special module and it's actually going to take up quite a bit of this talk, because by its very nature, it's all the other store modules depend on it, which means we have a central place where we can just like enable new features or implement new features, and they will automatically be available for all stores. That's not always the case. Sometimes we just have to do a few additional things in the stores, but especially when it comes to the Java 8 support, a lot of this stuff is actually in Spring Data Commons. So let me start with a demo. Wi-Fi, go away. Is that stuff, is the code here, like especially this, oh, Jesus. I don't fucking care. Sorry for that. Is that readable in the back? I guess it is. If not, just shout. The first thing we've added in, I think it was Fowler actually, is the support for the Java 8 datetime types on JPA. JPA, the last version is 2.1, which was released before Java 8, which means it requires Java 7 only because it's in Java E7. And so there's no mandatory support for Java 8 types in JPA per se. The latest Hibernate versions have introduced that support out of the box. If you're not on Hibernate, like 4.3 is the first JPA 2.1 capable version, then you can just like, I think, where is the setup? You can just go ahead and use the, here it is, basically register this class as in your persistence XML, or just make your persistence provider aware of it. That's just the boot way of doing that, and it will be able to store time zone independent date time types. Date time types with time zone information require a bit more work, because it basically means you have to split up the data into 2 columns and stuff like that. So it's not as straightforward, but everything that can be just translated into a legacy date can be made to work on even older JPA providers. That's just kind of neat. The other thing we have is that instead of, or the default mechanism for query methods and also the find one method on CRUD repository has been to return null if there is no result available. We've introduced support for JDK 8 optionals and Guava optionals. That's where the dependency comes in. And basically just naturally map null to optional. What is it in this case? Absent, or is it empty? Empty, I think it is on JDK. JDK8. Default methods work. That's just probably a no-brainer. And something that I'd rather like to show you in the MongoDB project is the support for streams as a return type. The interesting thing is here that one naively you could assume, okay, we can return a list, so I could just, like when on Java 8, I can just call a stream on it, but that wouldn't really give you any of real benefits except you're not having to call the method in the first place. As streams are usually lazy and only like iterated or used when the terminal operation is invoked on them, we can actually go ahead and use the persistence providers API. Let me just find the to-do here. We can use the persistence providers API to use a cursor instead of retrieving a list, loading all the result set into memory, and then returning it to you, and then allow you to iterate over all the stuff in memory. But we can rather basically back the stream that we return by the store-specific API, and then pull the data while you iterate over it. We do the same thing in JPA by just using store-specific or Hibernate-specific or Eclipse-Link-specific APIs to not reproduce a list, but allow you to pull on the cursor, basically. But the effect of that is basically easily shown here, where we just like execute a query, as you can see up there, and then output just the individual elements, right? And in the log output below here, I hope that's readable for everyone, I've turned on the logging for the persistence events. So you see that the first element is loaded. Here's on after load in the very back. So the first person is read. Is outputted here. Then the second person is read, outputted the third person. Yada yada yada. If you just use a standard list, that sort of looks different because of all the reading and conversion is happening beforehand and not while you're iterating the collection or the stream, then basically. Right, so basically delayed data access, especially if you're dealing with larger data sets, that's kind of helpful. That exactly sort of works with JPA, but then using under the covers. Okay, if it's Hibernate, we're using Hibernate-specific API to pull on a cursor. So some optimization here. And the other thing that's kind of handy and neat to use is completable future. So you can basically, in combination with add async, that's not really a feature that we introduce or something, that's just standing on the shoulders of giants of Spring Framework. Basically, completable future in combination with the add async annotation, and that allows us to basically write code that looks like this. So we say, okay, read all these things, and by the way, once you're done with that, so it's asynchronously executed query, then do that thing here, right? Then we iterate over the result, and then we have to wait until the future is done here. So there's a sort of a slight leap into asynchronous data access. That's of course basically the poor man's approach to it, because we're still, of course, that call is still blocking, it's consuming a different thread, yada yada yada. But there's a lot of work coming with, I'm not sure if Josh mentioned that in the talk before, Spring Framework 5 is going to have quite a significant rework in the entire framework to support reactive scenarios, RxJava or Reactive Streams API, and we're working with the MVC team to pull that stuff down into the data access areas where, like let's say Couchbase has a reactive driver. In the meantime, MongoDB has one. JDBC is sort of tricky because there's no really real reactive JDBC drivers out there. There's a few asynchronous ones, but that's just half the battle, unfortunately. But if you just want to use completable future, the repositories don't get in the way, right? If you're calling a few methods returning completable future from a controller, 3 different repositories, you can basically parallelize the access to that. All right. So much for the Java 8 support. I mentioned that we're leveraging the persistence provider specific API here in JPA, and in Mongo it's basically quite natural because you get a cursor anyway. It's just that we don't have to pull it on it up front. Yeah, the support for the date time types is also available for the 3.10 backport. So in case you're stuck on Java 6 or 7 and want to use the JSR 3.10 types, there's a backport library for that already. That's supported as well, just a different import. All right. Does any one of you customize Spring Data in terms of customizing the repository base class? Nope. Then just forget about this slide. It just got easier. Right? So there was a bit of factory and factory bean setup necessary for that. We just made it easier. The demo is kind of unimpressive because you just don't see any setup code anymore. So unless you know the pain of how it was before, then it's very hard to see anything cool in that. So, web projections, great topic. We have this module Spring Data REST within the Umbrella project, which is kind of the odd one out basically because it's not really a store project, but rather a building on top of the repository APIs of all the modules, and then exposing REST resources or HTTP resources for those repositories. And there was a feature that started in there that allowed you to sort of define custom views on the data you wanted to return. We called them projections, right? You can basically limit the amount of data that's actually returned, and you could also add or augment the data by invoking different other services easily. That stuff became quite handy, we thought, and so we moved it up to the Spring Data Commons project. Let me check where that piece of code is. Projections, yeah. So basically all the magic is in these 3 lines of code, and it's always kind of nice to show only very little code because that means you don't have to write much. What this thing does here is we call here's a find all method that takes a page request. So it's a paginating method basically on the user management, and as you can see here, maybe you can't read it in the back, it returns a page. The page has gotten within the Fowler release a new method called map that takes a Spring converter, which fortunately is a single abstract method type, so that you can feed it with a lambda instead, and that basically allows you to map the page into something different. So assume you have a page of users or a list of users, and you could just map them into list of user summary or the like, right? You don't want to expose all the data of the user, but only, and this is when the interface comes into play, we define an interface and say, oh Jesus, I'm sorry for that. Let's scroll up a bit. So we just define an interface and have this method in here that takes a value annotation. It could be just like a getter that basically mimics the getter on the user object, and the call is just forwarded, going forward. Come back to that in a bit. Or in this case, we can get access to the target, access the username, and turn that into string. The username is a value object in this example here, so it's not a string itself. That's why we have to do that. But at value, you can basically reference any Spring Bean or invoke any other method, pipe the target user, and let that do something with it. And what this line here basically does, it says projections. That's a projection factory, as we call it. You just go ahead and say, okay, dear projection factory, create me a projection of that interface. And here, by the way, is the target object. Right? So it takes the user, creates a proxy for the interface, backs the proxy with the user, and the outcome of that is that whatever ends up rendering this resulting list here will just see the interface, right? So it will just see the narrowed down API or the extended API using at value here. And so it's kind of a handy way to just like put different views on top of your domain types. We actually even started to use that the other way around, called inbound projections, where you can basically get you have a user form here. The user form is basically an alternative to a DTO. So in Spring MVC data binding, you usually or previously used form objects, kind of DTOs, fields with getters and setters and stuff like that. And unless you're using Lombok, then it's kind of a pain in the ass to write. So we thought, okay, why not just use the proxy, the projections the other way around? So you basically define which requests or which data you expect from your requests. You want to have a username, a password, and a repeated password, and then we just provide the Spring where is the web integration. So whenever you use that as an interface as a Spring controller method parameter, then we just create the proxy for you, bind the request data to it, and then you just get it. And in this case, I just have a bit of validation logic on that thing here in a default method. Kind of handy and easy. Basically avoids DTOs if not needed. Nothing really fancy, but kind of helpful in case you're not allowed to use Lombok, basically. Probably something worth checking out later and playing with it a bit. I don't want to change that. Thanks for asking. All right. Yeah, so we create proxies. You probably get a feel for that. The fact that we really like interfaces that can be backed by proxies and stuff like that for not only data access itself, but also like for creating these dedicated views. Outbound views I showed you with like just repeating the get methods on a field, and you can tweak stuff with add value. There is, we took that step even further with the Hopper release, and I think I'm going to come back to that in the end. You can even use these projection interfaces on repositories themselves with the Hopper release, and we will automatically be able to, let's say from that, what did we have? We had this user form. I assume there was, what was it, get username, get password or something. We could detect that these two properties are required to back this interface. And then we can optimize the query to only query for those two columns, right? So there's a lot of optimization possibilities that we can apply to those methods. But there definitely will be a kind of an announcing blog post once Hopper goes GA that will go into details of that. But we're basically pushing down that model down to the repositories again. It's available for JPA and Mongo already. All right. Query DSL. Who of you is using Query DSL? Anyone in here? Not many. That's good. Because then the others learn about Query DSL and its awesomeness. It's basically a library that is sort of in the realms of the JPA criteria API, but slightly more usable, to phrase it politely. In fact, it's a library for you to or to allow you defining type safe predicates basically on your object model. Let me check where's the example. Support for Query DSL predicates. There we go. So what you do with Query DSL, let me just, before we go into what's actually there, you can go ahead and you create a query, a meta model from it, and you just access, let's say, the Q user instance here, and then you define predicates by saying user dot, and not sure you can see that in the back. You basically get a meta model similarly to the JPA one, and then can say last name, and then say contains or something foo, right? And then you say and user dot first name yada 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 equals, let's try that, bar, right? If you've ever tried to write this kind of clause with the JPA criteria API, you're either a great fan of Star Wars because it lacks, or it seems to suffer from some severe Jodaism. You always have to say equal that is, right? So it's always kind of turning that thing around, sort of. That's way more readable. It can be just assigned and then reused later on and stuff like that. So it's kind of a neat API in the first place, and we've supported it, I think, not since day one, but it's been a very early addition to Spring Data in general. So the thing is that on the repository level, you execute those. Jesus, I have to zoom out again. Sorry for for that. There is a repository that has a find all method here. That takes this a predicate basically, and I could have built this predicate up myself, like I just did. And we got quite a few requests whether it wouldn't be cool that if you just provided a web request, you could just analyze the web request for request parameters that match the property names of the types, and then build a predicate for that, right? And that's basically what we ship with Gosling. So you basically just annotate your predicate parameter in a Spring MVC controller with query DSL predicate. If you return a result set of, or a result entity of user, so if there's some way for us to derive the domain type from the return type, then you can just leave that away here. But in this case, there's just a string, so we have to tell it, okay, we're looking for predicates that are tied to a user. And what we're going to do here, let me just start this thing, is we basically inspect the request for request parameters that match the user type, and pre-populate a predicate for you to just execute with it, right? Let me see whether that worked. I'm not sure. Yeah, that's the store finder. Is that what I was? That's kind of weird. Yeah, there's some other application running. The question is where it is. Yeah, let me. No, that's MongoDB. Oh, is it? No, that's it. That's it. Cool. Rerun this thing. Let's see whether that works now. You basically you can just like back a search form or something with it. That looks better. Tom, get started. There you go. So I have internet's not working. That's no problem. So it doesn't show the images. But I basically have a search form here where I can search for the first name, last name, nationality, what have you. And let's say I go for city, and I say new. And it sort of, in this case, you see, I put new here, and it returns New Haven, New York. So it's not an equals binding in this case, right? While when I go with, let's say, if I go with first name, and I just put an I in here, I don't get anything back. But if I type Fisher, then, oh, that's the first name. That's bullshit, of course. First name, I get everyone named Fisher. But if I restrict that to FIS, that just works as well. Let's see why that is the case. Let's go with the first name. I doesn't work, but Louis should work. Okay, so there's different ways of matching going on here, right? So for last name, it was kind of contains, and for Louis, for the first name, it's kind of strict matching. So how do you actually control that? The interesting thing is that there's an additional interface that you just implement on your repository. If it implements query DSL predicate executor, you get the query DSL functionality, and there's this binder customizer which you can just implement here. And in this case, we define, that's what I just showed you, right? So you get a type safe API. That thing here is code completable, and basically using the query DSL meta model. And I say, okay, whenever I get the first name, it should be bound using an equals binding here, right? So for everything that's string, so that's basically the fallback, the general mechanism. Everything that's string, it's supposed to be bound by contains ignore case, and we want to prevent people from searching for passwords, right? So I mean, would be hashes only anyway, but we just want to explicitly exclude those. So there's some kind of configuration API where you can define how this binding is supposed to happen, and yeah, so that's the query DSL binding support that you get out of the box. Either implement that with the repository, just like I did here, or you can also just have it a standard Spring Bean and register that on the annotation here. The binder, I mean, that would just work. Okay, is there anything more to show for the query DSL integration? Binding customizations, that what I just showed you. Okay, yeah. Bottom line is you can just get predicates pre-populated from web requests, that's it. And you customize the binding with that callback interface. So that's it for the comments, for the new stuff in comments. Spring Data JPA has enhanced JPA 2.1 support, which basically means there's a couple of things to mention here. First one is store procedures. So we created the ability to easily just execute store procedures, just like you would put add query on this thing here and define the query to be executed. You can just like annotate the name of the stored procedure you want to execute. If you can sort of use query derivation here as well. If you don't define the name explicitly, then it will just be the method name. That's sort of for consistency reasons, I wouldn't really advise unless you have made friends with the DBA and he or she really put nice procedure names, but they usually don't, right? Not because they're not nice, but because of that's just the way it is. So anyway, be friends with your DBAs. You're gonna need them. Store procedures. The other thing that JPA 2.1 introduced is fetch graphs. I've had I don't want to say heated debate, but intense debate with during the design phase of that with the authors. That my impression was that the way you define such an entity graph is rather verbose and rather cumbersome, and basically leads to annotation hell. Is Lukas Eder in the room? He's not, right? So. Ask Lucas if you meet him out there, the Juke guy, what he thinks of annotations. It's kind of, you can end up with a short class, but then like double the size or the number of lines of annotations on it to define a fetch graph, or 1 or 2 or something. We try to make this slightly easier, so you can either just annotate the fetch graph. Here you say, okay, we want to use, for that query, we want to use the product with tags fetch graph, which has to be defined on the product then, which already, well, yeah, it's basically saying, just give me that one attribute, right? The thing I was complaining about basically is that every attribute you want to define to be returned has to be put in this kind of sub annotation. So if you have 20 attributes you want to return, you have 20 nested annotations, which is kind of verbose. So we created some kind of shortcut and allow you to just say, okay, instead of defining this verbose entity graph, just return me or use these properties as fetch properties, right? That doesn't mean that the query gets entirely restricted to it. It's just that only these properties are pre-populated, and then all the other ones will be lazily accessed. There's different modes here for load and different modes for loading and fetching. So one is retrieving the things lazily, and one is just like loading the things that you specified. But bottom line here is you can use this JPA 2.1 feature with the repository methods. Done with that. Yeah, ad hoc fetch graphs are now a topic for JPA 2.2, supposed to be arrive before the next Ice Age, I hope. That means there's a ticket for that if you want to vote for it. There's a cool new spec lead from Prague who seems to be very active and very thoroughly looking at the tickets. So if you want to see that in the spec itself, just go to vote for that. We've upgraded the dependency to Eclipse Link 2.6 because that's basically the version that supports JPA 2.1. We still build against Hibernate 3.6, so we have a heart for the lazy upgraders, although it's highly recommended to use something 4-ish, if not 5 already. Attribute converters, I think I mentioned that. Okay, there's an option for disabling default transactions, but not sure this is too relevant actually. All right, we have until 2:15, right? Okay, so we're basically doing it. That's good. That's great. Spring Data MongoDB. There's always a bit of, it's kind of a side story. Not all of the Spring Data modules are actually maintained by the core Spring Data team. We're like 5 guys right now, all over the world, and like working on, like, let's say 80% of the modules. So MongoDB, JPA, core, REST, Solar, yada yada, a few of them basically. And it's usually the case if we add a new feature that requires dedicated store integration, we add it in one store and then try with the next release trains, we try to move all the other stores onto that new feature. And one of those features is the integration with Spring Security. The JPA module has had this feature for quite a while already. What it boils down to is basically where is it? There we go. MongoDB and security. Yep. It boils down to that you can use Spring Security expressions, so stuff that you would use inside an add secured annotation or something like that, like the Spring Security function, like has role or something, inside your query definitions. That's been available for JPA, as I told you. So in this case here, we basically would return all users for all persons for the admin. So if you're logged in as admin, if the current user is an admin, it will see all the persons if like in the database, and the if it's not an admin, then it would just like do an ID match on the principal, right? So it will just check that basically the persons that very user has created himself or herself. So that just works out of the box. There is we have this one feature open that's open for ages, unfortunately. That's asking for a kind of general mechanism to put these kind of limitations or additional criterias onto, let's say, the entire repository, right? So basically implement things like ACLs on the repository, implement things like soft deletes. That's stuff we're still working on. That unfortunately gets more complex the deeper you look into it, because you're running into all the corner cases, and yeah, so there's no easy way to do something like this on an entire repository and just basically flip it on with a switch right now. But the security expressions within the query declarations help quite a lot there, I think. So that's the stuff here in here. All right, Spring Security MongoDB. So available for Mongo and JPA as of today's production releases, right? I think I can just skip that Java 8 stuff here because I've shown you that in the comments section. The one, that's probably a good thing to mention here. The integration of the Spring Security expressions in the query is actually mostly done in the Commons module by this interface that I've listed here, Evaluation Context Provider. It's some kind of SPI which you could even use yourself to register custom spell functions, something that you have developed on your own, and make that available to the query execution. So basically that expression gets replaced with just a placeholder, and we remember that spell expression, and when the parameters are bound, we evaluate the parameters against that spell expression. And you can register custom functions in here. Spring Security is just using that kind of SPI and then plugging in or registering its functions with it. So that's not something we dedicatedly tailor to Spring Security, but it's basically open for extension for sort of everyone. Yeah, MongoDB 3.0 compatibility, they've changed a couple of internals and removed some deprecations. That's in Gosling as well. Streams you've seen. There's GeoJSON support and support for JavaScript functions, like executing JavaScript functions in the database itself, registering them in there, and then just calling the results for that. All right. Spring Data REST. How many of you have heard of Spring Data REST? Anyone using it? Cool. there's a gap in between. So I hope I can get you to play with it again. One thing we shipped and we actually added in the Gosling release is support for REST headers. So the Spring Data REST project is also, it's one of the most misunderstood projects of the umbrella, basically, because people think of it, okay, I can just take my database and put a REST front in front of it. That's not really the case, because actually to produce a good REST front end for it, we need to inspect a lot of things that you express in your domain model, the repositories being one part of that. And another thing that is quite important or quite interesting is the information about optimistic locking. So for JPA, you have this version annotation. You usually have registered the last modification date with your entities. But that stuff, that's database mechanics, right? And JPA has dedicated means for these things, which are for the version, basically e-tags, and the last modified is a dedicated header in HTTP. So we can actually go ahead and just inspect your domain model and basically remove those properties from the representation and put them where they actually belong in a REST world, which means HTTP headers. And that allows you, and that's probably if we do that, you can actually, and that's probably something you have to play with actually, we expose the optimistic locking property as e-tag, and we also automatically expose the last modified header, so that it basically allows your clients to say, okay, please do an update of this thing, but only if it's still in that version. Right? So conditional put requests. You can optimize your clients by saying, by issuing requests saying, please give me the representation of customer 4711, but only if it had been modified since 10 minutes ago, something, right? So and then you get back not modified if nothing has changed or something. So you can optimize the communication pretty easily without actually doing anything on the server side. So Spring Data REST will just like allow that optimized access, right, out of the box. Nothing for you to deal with in this case. The second thing we ship with where is it? Application, and I think that's going to be the sort of last thing before we finish with the Outlook. The other thing that we shipped with, I think with Fowler already, but polished up with Gosling is the HAL browser. This sample application is basically just using a MongoDB and providing some geolocation search on top of that MongoDB for Starbucks shops, right? There's a CSV file import, and then this thing here is actually, if there was internet in this place, it would actually use the Spring Data REST implemented API to repeat the search basically, and then put all these stores onto a Google Maps map, right? And it's using the API exposed at API. And let me just quickly go here and do that and say HTTP 8080 API. And then I'd get back the usual, okay, this is the home document that Spring Data REST exposes, and I can just follow the stores thing, and I just get back stores, and I can do searches and whatnot. But if you access the thing with the browser, you're not getting JSON back or something, but the HAL browser, that's some optional module that you can just like plug into your application. It's just another dependency, and it allows you to serve the API. It inspects the metadata format and can provide you, it can identify the links that are in there, and you can just follow those links. And then you get back the stores, and you can look at the individual stores and look at the links in there. So it's some kind of like API documentation kind of tool. And what we've added is the following. You see, if I just want to follow that link, I get this kind of text window that I have to fill out to basically populate additional data with it. And the original version of that HAL browser, it's not even written by us, it's by Mike Kelly, the inventor of the metadata format that we use, the HAL hypermedia application language. He built this thing in a way that whenever you wanted to issue a post request, it presented you a form where you had to put the JSON for it, right? So you had to kind of know which attributes you're going to set and stuff like that. Because we inspect your domain model quite heavily, we can actually go ahead and say we expose some metadata about your domain types. Application schema plus JSON. Does that work? Yeah, it works. So for this, because we know about the stores, we can basically provide a JSON schema about the stores, and then we customize the browser to consume that JSON schema. And then instead of presenting you a bloody HTML form field, where is it? You can just go and put this non-get thing here, and you actually get a form for what that stuff basically looks like. Or you could just like fill this out and just make the request and do things. So sort of the area of API documentation, and there's basically nothing customized here, just like adding that HAL browser module to your system and you just get this thing out of the box. Kind of funny stuff. All right. Finishing touches. HAL browser metadata. You probably can read this that later on. We've added a key value module. That's been most of it's sort of a little bit of Outlook because I probably just discussed this in the Outlook. We've added this key value module to be able to reduce a bit of coding effort from the store modules that actually back key or front key value stores. Gemfire, Redis. There's a Hazelcast module in the making and stuff like that. The key value module itself contains an implementation that just backs the repositories with plain maps, so that you can use it for testing purposes or something. If you don't actually have a database or a store at hand, you can just like flip on the map repositories and everything will just work as it did before. Query by example, I'm actually kind of reviewed that thing on the flight here. That's going to come for JPA and Mongo. So you just populate or partially populate a person instance and then say find everything that matches this kind of person. That's gonna be in there. Projections has already been shipped with M1 for Hopper. RC1 will also contain Redis repositories and Redis object mapping. So in other languages like there's OM, or I think in the Ruby world, there are object to Redis hash mappers. We're going to add one for Java here and then build repositories on top of that. We've upgraded the CreDSL dependency to 4.0 and also make significant upgrades to, there's a complete rewrite of Spring Data Neo4j in there. Couchbase is going to be 2.1. That's not correct. 2.1 is already out there. 2.1 is going to come. Spring Data Solr 2.0 will support Solr 5. And I've just heard yesterday that the Elasticsearch guys, also one module that we don't maintain, the Elasticsearch guys are planning to upgrade to, I think, what is it, 2.2 or something? Elasticsearch 2.2, the latest Elasticsearch version. There were also some kind of breaking changes in there, but they're going to be in Hopper. All right, that's basically it. What is it? 1 minute? So we have time for one question, two questions or something. If that doesn't work out, I'll be around until like 4:30 something. My flight is at 5:30, but
I'm interested into the spell integration you have shown with the Spring Security. Is it possible to use a T operator in that queries or in that spell expressions?
So the question was, what about the spell integration in the queries? There's basically general spell support is baked into it because we're just like evaluating all the queries using the spell. It's a spell query, or if you use the placeholders in there, you can just put in there everything that you would have done in Spell naturally. So everything that's supported in Spring Framework out of the box is supported there as well. This Spring Security specific integration is all about registering these special functions like has role or has permission or something like that. That's what Spring Security actually brings to the table and what you could leverage with your own Spell functions that you've registered yourself. There's some documentation there for how to do that. But things like filtering collections, you basically the root object gives you access to all the parameters that are handed to the query execution, and then you can just do whatever you want with them, like filter collections. Or I recommend not to overdo that because you basically start to program in strings again. But it's kind of helpful. I like the fact of, or the idea of registering functions for certain more complex functionality, because then it's just a keyword and you invoke something and then you're back to Java code where you can iron that stuff out. So that's kind of what I would recommend there.
Other questions?
All right. Thank you very much and enjoy the rest of the conference.